In this video, we're going to look at Venn diagrams. So a Venn diagram can be used to represent events graphically, and we can place either frequencies or probabilities in the regions of the Venn diagram. So we can either write them as the values themselves, and in some cases that will be easier, or we can write them as the probabilities, and in certain situations that will be easier. So we can see both. So first example. In a class of 30 students, 7 are in the choir, 5 are in the school band, and 2 are in both the choir and the band. So we've got 2 students who are in both. So first thing we're being asked to do is to draw a Venn diagram to represent this information. So we can draw our Venn diagram. So we've got our 2 intersecting circles as well as the box around it. The box is also part of our Venn diagram because that's going to represent the entire set. So then we've told of the class of 30 students, we've got the choir or the band or both. And on a Venn diagram question, it's always easiest to start in the center. So we've got 2 students who are in both. So I can put 2 in there. Now the reason why that's going to be useful for us is because since we're told 7 are in the choir, that 7 that are in the choir include the 2 who are in both. So if the total for this circle needs to be 7, I can do 7 take away 2, which gives me 5 in here. And since there were 5 students in the school band, 2 of those are also in the choir, they're already in there. So I can do 5, subtract that 2, and that's going to give me 3. Finally, since the class contained 30 students, all 30 students need to be accounted for in our Venn diagram. So 5 plus 2 is 7, plus 3 is 10. Since there are 30 students in total, it means there are 20 students who are in neither the choir or the band. For part B, we're being asked to find the probability that the student chosen is not in, so a student chosen is not in the band. So if we're choosing a student at random, we have 30 students in total and not in the band. We have, well, 5 who are in the band. So this 5 and this 20 are a total of 25 out of 30 who are not in the band. And finally, the probability that a student chosen at random is not in the choir or the band. So in neither of these, we've just got this 20 outside. So that is going to be 20 out of 30. And again, both of these could be simplified. I'll just leave those in the form that they are there. Unless a question asks us to simplify, we're not going to. The second example. So second example here, we're told a vet surveys 100 of her clients and she finds that 25 own dogs, 15 own dogs and cats, 11 own dogs and fish, 53 own cats, 10 own cats and fish, 7 own dogs, cats and fish, and 40 own fish. So lots of information we're given there, and we're being asked a few probability questions afterwards. Now, the first thing we're going to do is we're going to use that information to fill our Venn diagram, and the easiest place to start again is in the middle where we have all of the information. So if I look through our information, we can see that there are 7 who own dogs, cats and fish. So I can put my 7 in there. And then we can work our way outwards. So we're going to consider the intersections of 2 different regions now. So we were told 15 own dogs and cats. So dogs and cats is this region here. Now, since 7 are already in the middle, I can do 15 subtract 7, which is going to give me 8. So there must be an 8 in there. We were also told 11 own dogs and fish. So since 7 are already in here, 11 subtract 7 gives me 4 for this section here. And then finally, we were told that 10 own cats and fish. Since there's already 7 there, 10 take away 7 is going to give me 3 in here. So now we're left with these 3 sections and of course the section on the outside. So if we were told 25 own dogs, well, 8 plus 7 is 15, plus 4 gives us 19. So I can do 25 subtract 19, which is going to give us 6 here. So there are 6 people who own only dogs. For this area here, I've got 8 and 7 is 15, plus 3 gives us 18, and we were told that 53 people own cats, so it's going to be 53 subtract that 18, which gives us 35, and then we were told that 40 people own fish, so 7 plus 3 is 10, plus 4 is 14, and 40 subtract that 14 is going to give us 26 in here. So we've got our circles filled. So finally, the last thing we need to do is we need to find out how many people are on the outside of all of these circles just in the box here. And we know that there were 100 clients surveyed in total. So all of these, including what's on the outside, needs to add to 100. So if we add together everything that is in the circles, we had, well, cats was already 53. That's our largest number. 53 added to 26 is going to give us 79, plus 10 is going to give us 89. So we've got 89 in here. Since the total is 100, I can do 100 subtract 89, and that is going to be 11 left over there. So we've now filled out that Venn diagram. So our questions then: a client is chosen at random. Find the probability that the client owns dogs only. So if I look in my Venn diagram, dogs only is this area here, and that's going to be 6. So that is going to be 6 out of 100 because there were 100 people in total. Our second question is asking us the probability that a person chosen at random does not own fish. Well, we had 40 people in total who do own fish. That's this section here. So not owning fish must be the other 60. So that's 60 out of 100. And again, some of these will simplify. Finally, the question here, part C, the probability that the client does not own dogs, cats, or fish. So that's represented by the area on the outside. So that's going to be this 11. So that is going to be 11 out of 100. And that is our answer to that question there. That's the end of this video. Thank you so much for watching. For more A-Level and GCSE maths content, like and subscribe to N Jackson Maths on YouTube.